So now what we're going to do is put those four laws together. So it can be really hard to remember what goes with what. But the nice thing that I always remember is that the only two that go side by side are pressure and volume. Everything else is in a ratio. But we can actually make a combined gas law to show changing conditions, and then we can use any part we need. So if we put three of the four laws together, we could say that volume varies inversely with pressure, volume varies directly with temperature, and volume varies directly with moles of gas. So we don't have to do the fourth law because it's already kind of included in here. And so we could say that volume varies directly with moles and temperature and inversely with pressure. And again, we can replace this varies symbol with, or the proportionality symbol, with an equals a constant. We're going to switch from using a K in the constant to an R. And in the next lesson, we will talk about what this R value can be. But for now, we're just going to say, okay, if I took this equation and solved for R, I would get PV over NT. So then if I have this constant value R for PV over NT in changing conditions, I could say that P1 V1 over T1 is equal to P2 V2 over T2. Now I've left out the N because the moles of gas often remains constant, and if the moles are going to change or we're going to solve for the moles, we often use what we're going to do next day, which is the ideal gas law. But you could throw an N in there if you wanted to. So if you wanted one formula on your formula sheet, it would have all the variables that you might encounter. So what we can do is we can use this overall equation and then just cancel out the things that are already constant, so the things that aren't changing, and I'll show you what I mean by that. So if we take this first example, we have a gas has a volume of 4 liters, so V1 is equal to 4 liters at 1 atmosphere of pressure, so P1 is 1 atmosphere, and a temperature, so a T1 of 300 kelvins. And you'll notice they don't mention moles of gas, we just assume that remains constant. Then it says, what will its volume be? So what will be V2 if P2 is 2 atmospheres and T2 is 300 kelvins? So we're going to use the equation P1 V1 over T1 is equal to P2 V2 over T2. And the first thing I want you to notice is that the value of T doesn't change. So the temperature is constant. Now, if you put it into here, it wouldn't be a big deal. They would cancel it anyway. But you could actually use this equation without the T's, and all of a sudden you're down to Boyle's law. P1 V1 is equal to P2 V2. And we're going to take this equation and we're going to solve for V2. So we're going to divide both sides by P2, and we end up with P1 V1 over P2. And then we can just substitute in our values. So P1 is 1 atmosphere, V1 is 4 liters, and then P2 is 2 atmospheres. Plugging this into our calculator, everything is 3 sig figs. We didn't use the 1 sig fig temperature because that was constant, so we can answer to 3 sig figs, and we would get 2.00 liters. Often. One more. In the next question, it says a sample of diborane gas, B2H6, is a substance that bursts into flames when exposed to air, has a pressure, so a P1, of 0.454 atmospheres, at a temperature of negative 15 degrees Celsius, and a volume of 3.48 liters. If conditions are changed so that the temperature is now, so T2 is 36 degrees Celsius, and the pressure, so P2 is 0.616 atmospheres, what will be the V2? So again, we start off with P1 V1 over T1 is equal to P2 V2 over T2. And again, we don't need to include moles. They didn't mention moles, so we assume that moles are constant. But this time we have to keep everything else. Now, like I keep saying to you guys, you are more than welcome to plug in P1, V1, T1, P2, T2, and then you can do a multiplication and a division, and then one division, or you can rearrange this equation to solve for V2. If you're doing that, to get T2 by itself, or V2 by itself, you're going to multiply both sides by T2, and then you're going to divide by the P2. So that's going to get rid of the P2 and get rid of the T2, so you're left with just a V2, and I have a habit of always putting my unknown on my left. And then on the right, which is now going to be my old left, I'm going to have a T2 P1 V1, and it doesn't matter what order you write these in, over a P2 T1. Okay, now before I put these values in, I have to make sure they're all in the right units, and so the only thing I have to change is the temperature. So to each of the temperatures, I'm going to add 273.15. So for that one, I've got negative 15 plus 273.15, which gives me 258.15 kelvins. But remember, you got to maintain precision. So this temperature was accurate to the ones, and so we're going to say 258. So I'm going to keep the 0.15 on the end, but I'm going to treat this as 3 sig figs. And then this one too, I'm going to add 273.15, and I get 36 plus 273.15 gives me 309.15. This is precise to the ones, so I'm going to keep those 3 sig figs as well. And then I'm going to plug these in. So my T2 is 309.15, but it's only 3 sig figs. My P1 is 0.454, and my V1 is 3.48. Then my P2 is 0.616, and my T1 is 258.15, but again, 3 sig figs. So then I'm going to plug this all into my calculator. 309.15 times 0.454 times 3.48 divided by 0.616, and then I personally just hit divided by again, 258.15. Otherwise, if you're going to use multiplication, make sure you do divided by bracket this times this, unbracket. The value I get for volume is going to be, oh, I think I typed something into my calculator wrong. One sec. Yeah, I didn't know what I did there. I got an answer in the hundreds. I was like, that feels wrong. So my volume is going to change, and it's going to go down to and I'm going to 3 sig figs. So 3.07 liters as my final answer. So go give those ones a go. Again, you know, you could use this formula now for any of the laws and then just cancel out the things that are remaining constant or the things that aren't spoken about. And then you don't have to keep track of 4 different formulas. You can just keep track of the one. Just beware that we don't often use the n because the n is often not changing. So if you do want that last one, it was v over n is equal to, or v1 over n1 is equal to v2 over n2. And then you would have all of the calculations that we've talked about so far. Good luck.